So, am I going to give you one as tough as these? No. 7A, totally fair game. So while you're looking, I'll kind of start this because I have a feeling most of you got A okay. They want us to find the acceleration. You said, hey, this is a job for a free body diagram. What are the forces acting on this? You said mg, normal force, tension. I'll call that M3G because it's the third mass. No friction. Who's winning? M3G minus tension plus tension, no friction equals M all A. And then you get to stretch, and you end up with A being M3G divided by M1 plus M2 plus M3. Could all of you do me a favor and get your calculators out and just type that in? I'm not going to write out the numbers because I don't have much room, but can you go M3, 8 times 9.8 divided by bracket 2 plus 12 plus 8. Or if you're feeling really energetic, I think plus 22. You get really close to 3.6. I don't think it's bang on 3.6. What do you get? 3.5. Keep that on your calculator. 3.563? Okay. Now I'm going to erase all this because what I really want to focus on is B. B says find the coefficient of friction right there. Did anybody get this? I should ask that. Nice. What's this a good job for? On which mass? On the 2. So I'm going to do a nice big diagram right here, even though they gave me a picture, because I really want to visualize this. What are the forces acting on the 2? Hey, get the obvious one. Get the obvious one. Please, people, get the obvious one. Everybody? Okay. I'll call it M1G. I probably would have called the 2 mass 1 because it sort of appears first. Normal force. What else? Which way is the 2 accelerating? Which way is the 2 accelerating? Someone said up. Is accelerating up? It's flying into the air like Superman? Okay. Which way? I think it's accelerating to the right, which means I know there has to be a force pointing that way. Has to be. I'm not sure what it is. Well, is it tension? Is the rope touching the 2? Look at the picture. Is the rope touching the 2? It's not tension. I had somebody this morning says, is like F applied? Is there a mystery force coming from off the page? No. I had somebody say, is it M2G? Is the rope, or even is mass 8, is the 8 kilogram mass, is it even touching the 2? No. What is it? Then that was my aha moment. I said, Nick, imagine this 12 was a block of ice. No friction. Wouldn't it just yank right out and the 2 kilogram mass would drop straight down? You may have done that with a stack of magazines sometimes or something like that, right? Or a stack of books, yanked it out really quick. Yeah, I think what's pulling this forward is friction. That's the aha moment, because now, Kate, who's winning? Who's losing? It's a trick question. And you get this. Friction equals M1A. You get an easy, this is one of those that's so easy that it's tough, because that's really a pretty easy equation now that we got it. Friction, Callie, is what times what? There's the mu that I want to find. How would I get the mu by itself? I don't know the normal force. Oh, but look. In fact, I think it's going to be M1G. That A from your calc. In fact, the M1s actually end up canceling for what it's worth, but it would be 2 times answer button divided by bracket 2 times 9.8, and that is where the, oh boy, did I do that wrong, because I didn't do it on my calculator, Mr. Dewick. Wow, 2 times 3.563 divided by bracket 2 times 9.8. That's right, you guys typed it in, not me. That's where the 0.36 comes from. I would argue, although that's tricky, it's almost fair game. That free body diagram, it's the same free body diagram as for a car speeding up or a dragster speeding up, because friction is what makes the car go forwards. That would be fair game in my mind, because I've talked about that. Okay. While we're at it, number 12. A and B, to me, are fair game. A says, draw a free body diagram showing the forces acting on the box. I'm going to do that right here. So here's the free body diagram for part A. What are the forces acting on this box? Get the obvious one. And you know what? I could call it M1 because there's an elevator. I'm going to call it MB for box, and I'll call it ME for elevator. How clever is that? Which way, according to this question, is the box accelerating? Sorry? Someone said it. They're right. Yeah. Which way should I have a longer arrow pointing? What other force am I missing? Bigger, smaller, or the same size as mg? And how do I know? Apparently we're accelerating down, so normal force. I'll exaggerate it so it's obvious. You okay with that? Okay. B says, draw a free body diagram. I'm trying to fit this all on one page, so I'll do the free body diagram for the elevator on the right here. What are the forces acting on the elevator? Get the obvious one. I'm going to call that M elevator times G. What else? Brakes, friction, pointing up. Cool. How many of you got C and D? Marcus, I'm impressed. Well done. This is tricky. Well, Taryn, what does C want me to find? Of the... So the first thing that I did is I went, well, who's winning? M, E, G. Who's losing? Friction equals MA. And I would divide by, which M? E. I would divide by M. Problem. I don't think I know friction. So I know big M, or ME. I know G. Marcus, what did you do? Wait a minute, is the box inside the elevator? So aren't they accelerating at the same rate? I'm not going to find the acceleration of the elevator. I'm going to find the acceleration of the box, which must be the acceleration of the elevator. Oh, mass box G minus normal force equals mass box A. I don't know. Wait a minute. What does a scale measure? That's why they told me the scale reading. I see where we're going. So now I said, okay, I can definitely find the acceleration. It's going to be the mass of the box, 32. G, 9.8. Minus 210. They gave it to me. That was quite nice of them. Divided by 32. If you try that on your calculator, do you get 3.24? I hope. 32 times 9.8 minus 210 divided by 32. 3.2375? Okay. Sorry for those of you on YouTube. Meters per second square. Mud, what does D want me to find? I'll bet you now I'm going to use this equation that I crossed out, and I'll bet you, well, let's go see. It's going to be mass of the elevator times G minus friction equals mass of the elevator times, let's get friction by itself. Swappy dance, I think. It's going to be mass of the elevator times G minus mass of the elevator times A, and if you don't mind, I'll put friction. Do I know the mass of the elevator? Do I know G? Do I know the mass of the elevator? Do I know? That's why I had to do that first. If you're wondering, hey, Mr. Newick, this doesn't seem that bad for a scholarship question, what they actually did on this is they only asked part D and didn't walk them through anything of A, B, or C. So you had to clue in, Brea, I guess I got to do a free body diagram for both of them. And I need A to find friction. I don't know A. I can find A for the box, which is going to be the same. And I know that a normal force is what a scale measures. So you have to really put some good thinking there. Is that all right? Are there any other questions from any of the homework assignments, lessons 1, 2, 3, 4, 5, 6, and or 7, or 8, that you would like me to go over? Now is your chance to ask. You can also ask during classes we're just working.